Section 2.1 on linear equations. So in this section we're going to talk about linear equations. Linear, again in math, is a fancy word for degree 1. An equation is any algebraic expression that has an equality in it. So we're talking about linear equations in this section, so let's get started. A linear equation has the form. It looks like this. You have a times x plus b is equal to 0, where a and b are real numbers. Okay, so this is a linear equation in x because the degree of x is 1. It's linear. It's an equation because we have an equality in it. Okay, so this is a generic form of a linear equation. Okay, now what does it mean to find the solution of a linear equation? So let's talk about that. A solution to a linear equation is the values, and I'll put the word s in parentheses, values of the variable for which the equation is true. That is, the left hand side is equal to the right hand side. Okay, so our goal out here in this section is to solve linear equation. We want to solve. So when we solve a linear equation, we find something called a solution. So a solution to a linear equation is the values of the variable for which the equation is true. That means the left hand side is equal to the right hand side. Okay, so our goal is to find the solution. So how do we go about doing that? So let's take a look at part B, solving a linear equation. And that's the same thing as that is finding the solution. That is finding the solution. That's what we want to do. We want to find the solution to the linear equation. Okay, now to do this we need to follow a few simple steps. Okay, so the first thing we want to do is we want to get rid of the parentheses. Next thing, we want to get rid of the fractions. And to do this, basically what we're going to do is we're going to multiply both sides of the equation by the common denominator, which I'll abbreviate CD. So this is an important step that you should always remember for future, because we'll come across that idea many times. Anytime you want to get rid of fractions, you multiply by the common denominator. Okay, in different situations we'll have to apply that idea differently, but the idea is the same. There's common denominator involved. The next thing is we want to isolate all, I'll capitalize that, variable terms on one side. Variable terms on one side. Okay, so we want to isolate just all the variable terms on one side. That means you move everything else to the opposite side. And then the last thing we want to do is we want to isolate just the variable. So there are just 4 simple steps to follow when you're solving a equation, right? That'll give you the solution, but there's one last step that you should always do. A lot of the time students don't do that because they're always in a hurry, but you should always check your solution. You should always do that. Nowadays with fancy calculators, that is very easy to do, and I'll show you guys how to do that. To check your solution, what does that mean? You take the value of the variable and plug it into the equation and see if it's true, if the left hand side is equal to the right hand side. That's all we want to do. Okay, now in some cases it is very important to check your solution, so I'll put that note, especially if the variable is in the denominator check for division by 0. One of the rules in math is we can never divide by 0. So if the variable is in the denominator, then maybe for some value of the variable that denominator can be 0, and then you'd end up dividing by 0. So we always want to avoid that. I really do want you to check your solutions. I will do that for a few problems here in the video, but in general, just for the sake of time, I won't check them for every problem, but I will do for the first few problems to get the point across. So you do need to take a few minutes and check the solutions. Okay, so let's get started. Take a look at some examples. So all of these examples will say solve for, I'll use x as my variable always, but you're not limited to x. It can be any variable, but I'll use x just so it'll be easier to solve. Well, let's mix it up. Let's not be tied down to x. Let's just say solve. So let's look at the first problem. So let's say if I have 3 times 2x minus 1 minus 4 times x plus 2 is equal to 5 times 3 minus x. So I want to solve this equation for x. So let's do that. The first thing is get rid of all my parentheses. So I'm going to go ahead and distribute here. So I get 6x minus 3 minus 4x minus 8. Remember, you're distributing negative 4. Please remember that. That's a common mistake students make. They'll forget that. 15 minus 5x. So I got rid of all my parentheses. I have no fractions to worry about. So let's move all the variable terms on one side. This term has a variable in it, this term, and this term. So they need to all be on one side. Since I already have 2 of these on the left, I'm going to move this 5x to the negative 5x to the left. Anytime you move any term from the left to the right or from the right to the left of the equality, all you have to do is change the sign. So if this is a negative 5x, when I move it to the left, it'll become a positive 5x. So I get 6x minus 4x plus 5x. So this is a term that came through. On the right I have 15 still. Now I'm going to move 2 numbers on the right. So I'm going to move this 3 and the 8 to the right. Okay, they're both negative, so when I move them to the right, they'll both become positive. So you get plus 3 plus 8. Okay, so on the left we get 6x. We can collect these x's. We can add the coefficients in the front since they're all the same variable terms. So we get 6 minus 4 is 2. 2 plus 5 is 7x is equal to, I get 15 plus 3 is 18. 18 plus 8 is 26. So we end up with x is equal to 26. Oops, I'm getting ahead of myself. So we did step 3. Now we want to isolate just the variable. I want this x by itself. So I want to get rid of this 7, which is attached by multiplication. So you do the opposite. You divide both sides by 7. So the 7's cancel here. So you get x is equal to 26 over 7. Do not convert the answers to decimal unless it's a word problem. If it's not a word problem, always leave your answers in exact form. Okay. So now let me show you how to check your answers. You can take your calculators out, your TI calculators, and you can easily check this. Okay. So the first thing I want to do is when I want to check my answer, I want to take this answer that I found and store it into the variable x, because that's what x is. So let me show you how to do that on your calculator. You can take 26 divided by 7, and here's your store key here. So you can click on that store and here's your variable key x, so it's going to store that into x. Even if your variables was something else, let's say it was y, m, n, you can still store that into x, and you can just think of your variable as x instead of y. Now all you have to do is type the left hand side of your equation in your calculator just as it's given to you. So you take 3 parentheses 2 times x minus 1 close parentheses minus 4 parentheses x plus 2. So I'm just entering the left hand side as it's given to me. Press enter. So my left hand side is equal to that. Now let's do the same thing with your right hand side and see if those two values are the same. So I take 5 parentheses 3 minus x close parentheses, and they are the same, so we know the solution we came up with was right. That's all we need to do to check your answers. Just plug in store the value of the answer you got into the variable x, and then just check the two sides. I'll show you that to you again in the next example. So let's do problem 2. In problem 2 we have x minus 2 over 3 plus 1 is equal to 2, let's change these to m's, make them different, m over 4. Okay, and let's make this a, mix it up a little bit, how about 8? Okay, so now in this equation, this is an equation, it's linear because the power on the variable is 1. So it's a linear equation. So you can clearly see it's a linear equation. The only thing different about this equation as opposed to the last one is we have fractions. So my first step should be to get rid of those fractions. And because it's an equality, whatever I do on one side I have to do on the other side. So just remember that. I'll come back to that. So to get rid of the fractions, the first thing I need to do is find my common denominator. To find the common denominator, let me just show you this once. But remember, the common denominator is a number. It's a smallest number that's divisible by 3, 8, and 4. Okay, that we are looking for a smallest number that 3 divides, 8 divides, and 4 divides. A good way to find the common denominator is to take each of your fraction and break it down into its factors. 3 is just 3. 3 cannot be broken down. It's a prime number. 8 can be broken down into 2 times 2 times 2, so you can write it as 2 cubed. And 4 can be broken down into 2 times 2, which is 2 squared. So once you do that, your common denominator, to find your common denominator, all you do is take each factor to the highest power that you have. My factors are what? 2 and 3. Those are my only two different factors I have here. So you take 2 to the highest power. Out here the power of 2 is 2, out here it's 3, so the highest power is 3. And you take 3 to the highest power, which is just 1. So my common denominator is 2 cubed is 8 times 3, which is 24. Okay. Now I do want to caution you that when you try to find the common denominator, you're looking for the smallest number that's divisible by 3, 8, and 4. 48 is another number that's divisible by 3, 8, and 4, but we're looking for the smallest one. Okay. Now that we have a common denominator, I'm basically going to multiply the left side by my common denominator, which is 24. I'm going to multiply the right side by my common denominator, which is 24. Remember, our goal is to get rid of those fractions, because once we get rid of the fractions, then it becomes a problem just like this. Okay, so let's do that. So when we multiply both sides by the common denominator, and the reason for that is because of the equality, we can't just randomly do something to one side and not to the other side. We got to keep the balance. So we're going to go ahead and distribute here. So we get, another way to think of it is, instead of thinking of it as multiplying both sides by the common denominator, you can think of it as multiplying each term in your equation by the common denominator. That'll be the same thing. So that's what I'm going to do. I'm going to take 24 and multiply each term of the equation by my common denominator, because when you distribute this 24 on the left side, that's what you're doing. Okay, so that's what we have. Oops, let me make this a 3, because else I could have reduced that right away. Okay, alright, so let's go on. So on the left here, This is 24 over 1. This is multiplication, so I can cancel anything from the top and bottom. That's what we learned when we did the section on rational expressions. So I'm going to cancel this. 3 goes into 24 8 times. So you get 8 times m is 8m. 8 times negative 2 is negative 16. If you notice, a key thing to take away from here is we don't have a fraction here. We don't have anything in the denominator. That's really good. This is 24 over 1. There's multiplication. You can cancel things from the top and the bottom. 8 goes into that once and into that 3 times. 3 times 1 is 3. Again, no more fractions there. Again, multiplication here. I can cancel. 4 goes into that once and 4 goes into that 6 times. 6 times 3m is 18m. We got rid of our fractions, so now this is still a linear equation. So let's move all the variable terms on one side. In the previous problem, I moved the variable terms on the left. You don't always have to do that. You move it according to the convenience. Out here I already had 2 variables on the left, so I moved this on the left. Okay. Over here, just to be different, I'm going to move the variable on the right. So it's a positive 8m. So when I move it, it'll become a negative 8m. Anytime you move things on either side of the equality, you change the sign. So I get negative 16 plus 3, that stays on the left. I get 18m minus 8m. So on the right I can collect these terms. I can add the coefficients. 18 minus 8 is 10m. And on the left I get minus 13. So now that we isolated all the variable terms on one side and combined them, now we want just the variable by itself. So I want to get rid of this 10, which is attached by multiplication. So I divide both sides by 10, do the opposite. The opposite of multiplication is division. So the 10's cancel on the left. So that tells me m is equal to minus 13 over 10. So now if you're not sure of your answer, let's go back and check it. Alright, so here's my equation. I'm just going to get rid of some of this other stuff. So let's check this. Okay, so what do? Bring up our calculators, store this answer in the variables. So I'm going to clear this. So I'm going to take negative 13 divided by 10, and I'm going to store that. Instead of storing into m, I'm just going to store it into x. It's just easier to use that x key. Okay, enter. Now I'm going to type in my left hand side just the way it is. On the top I have 2 terms, m minus 2, so I'm going to need parentheses. So I'm going to go parentheses x minus 2. Remember, m is replaced by x, divided by 3, plus 1 divided by 8. That's what we have on the left. Press enter. So that's the value. On the right we have 3m over 4, and instead of m we have x. Again, I'm going to get 3m or 3x divided by 4, and we get exactly the same value. So that tells me that this is the right answer to that problem. It takes literally a second to do that. Please do that. It will just make sure that you did all your work correctly. You didn't make a sign mistake or make an algebraic mistake. The next problem is another problem that has fractions in it. So we have 5 over 2y minus 6 is equal to 10 minus y over, let me actually do a different problem first before I do that one. Let me do this one. 2y over y plus 3 is equal to 3 over y minus 10 plus 2. So let's do this. So this problem again is a linear problem because the degree on y is 1 here. Okay. But it has fractions, so let's take care of these fractions first. So let's get rid of those fractions. So we need to find the common denominator. To do that, we have to factor this. If you recall, in the previous problem we factored the 8 and the 4, and then we found the common denominator. So that's what we need to do. This is already factored. It cannot be factored any further. So is this. But if we could, you should factor them. For example, if I had y minus 4 here instead of this, then I would have factored that into y minus 2 and y plus 2 using the difference of 2 squares formula. Okay, so let's go ahead and assume that this is what we have. So now we want to basically find the common denominator. Since it's already factored, you take each factor to the highest power. The highest power of y plus 3 is 1. You can see that there's no other y plus. And the highest power of y minus 10 is also 1. So that's my common denominator. So let's do that. What do we do? Multiply each term by it, right? Technically we multiply both sides by it, but I showed you that here when we multiply this side by 24, in essence we distribute and we are multiplying each term by 24. So it's easier to think that way. Multiply each term by the common denominator. So I get y plus 3 times y minus 10. You multiply that by 2y over y plus 3 is equal to y plus 3 times y minus 10. You multiply that by 3 over y minus 10. And then you have 2 times y plus 3 times y minus 10. Okay, so we're multiplying each term by the common denominator, and again we're doing that to get rid of the fractions. So if you notice in the first term here, if you just pay attention to that term, ignore everything else, you have multiplication, multiplication. So we can cancel things from the top and bottom. So the y plus 3's cancel. So I can go ahead and distribute this. So I get 2y squared minus 20y. Okay. On the next term here, again multiplication everywhere over 1, so I can cancel things from the top and the bottom. I distribute the 3, so I get 3y plus 9. Okay. On this side here, I have nothing cancels because there's nothing in the denominator. So all I have to do is multiply this and then multiply whatever I get by 2. So you can do that on the side. So let's assume you did that on the side. You guys know how to FOIL it and multiply. So I'm just going to do that on the side. So I get y squared minus 10y plus 3y minus 30. So you get y squared minus 7y minus 30. Okay, so that's what we end up with. So now I want to take this and multiply that by 2 because there's a 2 in the front. So you get 2y squared minus 14y minus 60. Always do your multiplication and things like that on the side so you don't clutter your problem and make a mess out of it and end up making mistakes. The key thing now we have, if you notice, is no more fractions. Okay, so let's go ahead and solve this. Now on the surface it looks like it's not a linear equation because the highest power, it seems it's 2. You can see that, but if you'll notice they will cancel out because I have a 2y on this side, I have a 2y on this side, so they will cancel. They're exactly the same, so you can just cancel them from both sides. Now what do I want to do? Move all the variable terms on one side. So I'm going to move everything to the left this time, so you get 20y. I'm going to move this 3y to the left. It's a positive, so it'll become a negative 3y. I'm going to move this negative 14y to the left. It's negative, so it'll become a positive 14y. And on the right I have 9 left minus 60. That's the only thing that's left on the right hand side. So let's collect these y terms on the left. Add the coefficients. Negative 20 minus 3 is negative 23. Negative 23 plus 14 is negative 9y. Okay. The next thing we want to do is what? Add the terms on the right hand side, right? So if you add the terms on the right hand side, what do we get? We get 9 minus 60, which will give you negative 51. So that's what we end up with on the right hand side. So we collected all the variable terms on one side, we added them up. What's the next step to do then? Well, the next step is we want to just isolate the variable by itself. So I want to get rid of the 9, which is attached by multiplication, so you do the opposite, which is division. So you get y is equal to negative 51 over negative 9. And you might think, oh, I'm done. But keep in mind, you should always try to reduce your answers if you can. So for example, in this case, I'm just going to do it on the side here since I have no room at the bottom. 3 divides both of them. So I'm going to divide the top by negative 3 and by negative 3 because there's a negative common in both. So I get, if you divide 51 by 3, we get 17. And if you divide negative 51 by negative 3, we get 17. If you divide negative 9 by 3, we get just 3. So there's your answer. Okay. And this is one last time I'm going to show you how to check it. So let's go ahead and check it. So I'm going to store this answer into y. Instead of y, I'm going to just store it into x just for convenience. So I get 17 divided by 3 store x. Okay. Then I'm going to just type in my left hand side just the way it is. So I have 2y. Instead of 2y, I'm going to use x for y. Divided by, now I have two terms in the bottom, y plus 3, so I need parentheses, so I have x plus 3. That gives me that value. I'm going to do the same thing on the right. I get 3 divided by, again I'm going to use parentheses since I have two terms. I have x minus 10, and then I'm going to add the 2 to it, so you get plus 2. And there is the same exact value, so I know the two sides are the same. Now, in this case, even if you decided not to check your answers on the test because you were in a hurry or you didn't have time, you should at least make sure that you check for division by 0, because the variable is in the denominator, and I did point that out to you. Okay, if you remember, especially if the variable is in the denominator, check for division by 0. So let's do that. Instead of trying to plug your answer into it, you just look at the denominator and ask yourself, for what y will this be 0? Clearly, if y was minus 3, you get negative 3 plus 3, you'll get 0. So if y is minus 3, is minus 3 my answer? No, so I'm good. When will this be 0? When y is 10. Is 10 my answer? No, so we're good. So neither one of the answer is not going to cause division by 0. So a good way to check for division by 0 is just look at the denominator and ask yourself, for what x or y will that be? 0. In this case it's y. Okay, and then you want to make sure that your answer is not one of those values. Okay. Now before I go any further, I do want to show you one little trick that you can utilize when you're solving equations that have fractions. Okay, so far our goal is always going to be to get rid of fractions, and we will use that goal throughout this course. Always remember that if you have an equation with fractions, always try to get rid of those fractions first right away, because those fractions will cause all kinds of problems later. If you get rid of those fractions, and the equation becomes very trivial and you can solve it very quickly. Let me do one more example on that, and then I'll show you that little trick on how to deal with equations with fractions. Okay. Let's say that if we have an equation that's a little bit more complicated in the denominator than what we have had so far. Okay, so far we've had just some basic polynomials in the denominator, but what happens if we have something a little bit more complicated in the denominator? So let's take a look at this. So let's say if you have 3x plus 2 divided by x squared minus 3x minus 10 plus 1 over x plus 5. Let's make it minus. Actually, and also make this minus, is equal to 2x minus 1 over x plus 2. Okay, so this is an equation, you can see has fractions. As soon as you see equations with fractions, light bulb should go off. I should get rid of those fractions. Now to get rid of fractions, you need to multiply everything by the common denominator. So we have to find the common denominator, and to find the common denominator you always have to first factor the denominator. So if you recall, this one's already this one cannot be factored any further, this cannot be factored any further. Okay, cannot be broken down any further, but because this is degree 2 with 3 terms and nothing in common, so I can use the AC method to factor this, and you guys know how to do that. I'm just going to do it on the side. We have x squared minus 3x minus 10. So I can write x, I want two numbers. When I multiply, I get negative 10 because it's 1 times negative 10, and when we add, we get negative 3. So the numbers are negative 5 and positive 2, because if you have negative 5 times 2 is negative 10, and negative 5 plus 2 is negative 3. So you can see that. If you cannot figure those numbers out in your head, you can always draw the little tree that I showed you when we did the section on factoring. So I'm going to replace this right away with x minus 5 and x plus 2. Okay, so now that we did that, let's go ahead and find a common denominator. What's my common denominator? To find the common denominator, you take each of your factors in the denominator to the highest power. So let's start with x minus 5. X minus 5. What's the highest power of x minus 5? Out here it's 1. Out here it's 1. So the highest power is 1. Then I can take my next factor, x plus 2. What's the highest power of x plus 2? 1, 1. So that's all we have. So that's my common denominator. So I'm going to start by multiplying each side, or by both sides, by the common denominator, which, if you remember from the previous example, basically means you're multiplying each term by the common denominator. So I'm going to multiply each term by the common denominator. We're not trying to make all the denominators the same, so don't fall under that trap. We're actually trying to get rid of the denominators from both sides, okay? Alright, so on the left hand side, because this is 1, this is multiplication. If you just pay attention to this term here, I can cancel things from the top and the bottom, so this will cancel. So I just get 3x plus 2 minus, out here this cancels, because if you just pay attention to this term, this is over 1. I can cancel things from the top and the bottom because we have multiplication. And then I'm going to have to multiply x plus 2 by 1, but no, it's not really 1, it's actually minus 1. So please don't forget those negative signs. I want to distribute that. Negative 1 times x is negative x. Negative 1 times 2 is negative 2, is equal to, out here again in this term, you can see x plus 2's cancel. So you're left with this product here, because this is over 1. So you can go ahead and distribute here. So we get 2x squared, okay, minus, we get 2x times negative 5 is negative 10x, minus, actually let me do this because I don't want quadratics to pop up. Let's just make that a 2. That'll be easier. Okay, sorry about that. Okay, so we get 2x minus 10. So we're just distributing here. Okay. Alright, so now that we have that, it's a linear equation. Degree is 1. It's an equation because it has an equality, so move all the x terms to one side. So we get 3x minus x. These two stay on the left. I'm going to move this 2x to the left, so you get negative 2x is equal to negative 10. And you move these 2's will just cancel because it's a positive 2 and negative 2, so you just get that. So on the left, if you collect the terms, we get 0 is equal to negative 10. Now just think about it for a second. Is the number 0 equal to negative 10? Only negative 10 is equal to negative 10, and only 0 is equal to 0. So that tells me that this is not a true statement. That tells me that this problem has no solution. Okay, that means we cannot find a value of x for which the two sides are going to be the same. So it's a nice problem to illustrate the idea of no solution. You always get no solution if you end up with something that's inconsistent. Like this statement is inconsistent because 0 cannot equal to negative 10. So that tells me that the problem has no solution. Okay, let me do another problem. How about this one? I have 3x minus 2 plus 5 is equal to, I have 5x minus x let me make this a 4, x minus 2. Okay, so let's take a look at this problem. Again, I have parentheses, so we have to get rid of those parentheses when we are solving. So let's go ahead and distribute here. So we get 3x minus 6 plus 4 is equal to 5x, and we're going to distribute the negative 2. So you get negative 2x plus 4. I'm going to move all the x terms to one side. So we get 3x minus 5x plus 2x is equal to 4 minus, I need to make a few changes, I'm sorry about that, negative 2. So let's make this, I'm sorry, I'm trying to illustrate a point, so I do need to fix this, make this a plus 1. So this will become a, when you distribute, it will become a negative 2. So I'll have negative 2 plus 6 minus 4. Alright, that's better. So on the left, if you collect the terms out here, we get 0. Okay. On the right, if we collect the terms, we get 0. So in this case, 0 is always equal to 0. So that tells me that this equation really is something what we called an identity. Anytime you end up with 0 is equal to 0 when you're solving, it tells you that it's an identity, because that tells me that this equation is true for any value of x, not just one particular value, but for any value of x. So let me go ahead and prove that to you. Okay, so let's go ahead and pick a value of x and try it on a calculator. So we'll try two values just to prove it. So let's pick something really odd. Minus 75. Oops, clear. Minus this minus we want to use, sorry about that, store x. So I'm going to plug that in. So I have 3 parentheses x minus 2 plus 4. That gives me negative 227. And on the right I have 5x minus 2 times x plus 1. That gives me negative 227. So that worked. How about a different value? Let's pick a different number. Let's pick 5. Let's store that into x. So let's do the same thing again. If you don't want to keep typing the left hand sides again, you can use the entry command on your calculator, the yellow command there. Oops. So you can just go second enter, second enter, second enter, and then so that gives you this value. But let's go one more back. That gives you that left hand side. So you can press enter. Then you can just do second enter a couple more times to get the right hand side. There we go. Press enter. There you go. 13 and 13. So you can see that the two sides are the same. So anytime you're solving an equation, you end up with 0 is equal to 0. You really, in essence, end up with infinite solutions, because any value of x will work, any real number for x will work, and we call something that an identity. Okay, so let me write those things down for your benefit. Note 1. If while solving a linear equation, the result is 0 is equal to some number, then the equation has no solution. And I showed that to you earlier. Okay. The second thing you could do is, the second thing you need to know is, if while solving a linear equation, the result is 0 is equal to 0, then the equation has infinite solutions, and we call the equation an identity. Okay, so those are two things you should know. You might come across equations that work that way. Okay, all right. Oh, before I forget, let me just tell you the last thing that one other note. This is a separate note from that. Okay, if two fractions are equal, then in an equation equal, then we can cross multiply instead of multiplying each term by the common denominator. Now this only works if two fractions are equal. This is just, if two fractions are equal, then we can use this idea. We can still do them by multiplying each term by the common denominator, but by cross multiplying it speeds up the process. That's the only advantage to cross multiplying. So let's take a look at an example of that. So please don't abuse this in situations where you don't need to do this. This only works when you have two fractions that are equal. Okay, so a lot of the time students will start abusing this when two fractions are not equal. Okay, so here's an example. Let's say if you have 2 over x plus 2 is equal to negative x over x squared plus 5x plus 6. Clearly I have an equation. I have two fractions equal, so I can cross multiply. I can take 2 times this and that. So let's do that. 2 times x squared plus 5x plus 6 is equal to negative x times x plus 2. Make sure you guys put parentheses because this has multiple terms, this has multiple terms. Now, the whole idea out here was to get rid of the fraction. So normally we would find the common denominator and do that. That would work perfectly fine, the common denominator method that I showed you earlier. But when you have two fractions equal, this is much faster. You don't have to worry about finding the common denominator. So let's go ahead and solve this. We're going to get rid of the parentheses, so we get 2x squared plus 10x plus 12, okay, is equal to, so what do we get on the other side there? Okay, we would end up with is equal to negative x squared minus 2x. Okay, so that's what we end up with on the right hand side. Okay, alright, so now we want to go ahead and solve this equation. So we move all the x terms to one side, so we get 2x squared plus x squared plus 10x plus 2x. And I did pick a bad example here because is equal to, let's see, plus 12 is equal to 0. So I move these two terms to the left. So we add these up, so we get 3x squared plus 12x plus 12 is equal to 0. Okay, so now we can go ahead and divide everything by 3 because you have an equality, so I can divide both sides by 3. Whatever I do on the left I can do on the right, and the reason for that is because there's a 3 common in all the terms. So always try to make your numbers smaller. So I'm going to divide by 3, so we get x squared plus 4x plus 4 is equal to 0. Now, we haven't done problems like this because technically this is degree 2 and we are trying to solve degree 1 in this section, but let's go ahead and do this anyway since we started down this path. Okay, I can easily factor this. Do you guys follow? So if you factor this, you get x plus 2 and x plus 2. You can do them on the side. You guys know how to factor, right? We want two numbers. When we multiply we get 4, and when we add we get 4. So we get 2 times 2 is 4 and 2 plus 2 is 4. So this product here is 0, so that tells me what? The only way when you multiply two numbers and the answer is 0 is if one of them has to be 0. So that tells me x plus 2 is 0 or x plus 2 is 0. So we get x is equal to negative 2 and we get x is equal to negative 2. So there is your answer there. They both happen to be the same. But if you go back and try to check the answer, if you notice over here, if x is negative 2, you'll get negative 2 plus 2, which is 0. So this will become 0. Can we divide by 0 out here? No. That tells me that neither one of these answers are going to work, so that this problem has no solution because you'll get division by 0 for that value of x. Okay. And this was, I'm sorry about that, this was a pretty terrible example here because we ended up with a problem that we still haven't learned how to do. We are going to learn how to solve degree 2 problems in section 2.4. So we got ahead of ourselves, but that's alright. Let me give you one that we can do from this section that is similar to cross multiplying stuff. Okay, so that way you guys can learn how to do that too. Okay, so let's say that if I have let me actually show you that if I had done this problem the old way, it would still work out fine. Let me show you that. Let's do it that way. We did it by cross multiplying and we got the answer of 2, which is fine, which is the right value of x. It just didn't work because it caused division by 0. But let me go ahead and do it like the old way. How would I do it the old way? Instead of cross multiplying, to get rid of this fractions, I would multiply each side by the common denominator. So let's do that. So the first thing I have to do is factor this. So to find the common denominator, we always have to factor the denominators. I want two numbers. When I multiply, I get 6, and when I add, I get 5. The two numbers are 3 and 2, because 3 times 2 is 6 and 3 plus 2 is 5. So this denominator is actually x plus 3 and x plus 2. So let's do it that way. So my common denominator is x plus 2. The highest power of that is what? 1 here and 1 here. So the highest power is 1. And the highest power of x plus 3 is also 1. So I'm going to multiply each term by the common denominator. So I get x plus 3 times x plus 2. I get 2 over x plus 2 is equal to x plus 3 times x plus 2 times minus x over x plus 3 times x plus 2. Okay. On the left, since I have over 1, I have multiplication. I can cancel things from the top and the bottom. This cancels. So 2 times x plus 3 is 2x plus 6. On the right here, all of this will cancel because this is over 1. So you're just left with minus x. So this is a lot easier. I want to solve for x, all the x terms on one side since it's linear. So you get 2x plus x. This negative x becomes positive. The 6 goes on the right. Get this. So I get 3x is equal to negative 6. I want to solve for x. So I want x by itself. Now get rid of the 3, which is attached by multiplication. So you divide. So you get negative 6 over 3. So we get x is equal to negative 2, which is exactly what we had, which did not work. So you can actually see in this case, this works out much better. Okay, because we didn't end up with degree 2 like I did when we cross multiplied, but you can still use cross multiplying when we have two fractions equal. Okay, so let me give you an example of that. So let's say if I have something like this, if I have x minus 1 divided by x plus 2 is equal to x plus 3 over x minus 1. I have two fractions equal. Okay, I can find the common denominator, which in this case is just x plus 2 times x minus 1, and multiply each side by it and do it that way. Or, because you have two fractions equal, we can just cross multiply. So let's do that. So we get x minus 1 times x minus 1. Make sure you guys put parentheses since there are two terms now when you're moving them. Then I have x plus 3 times x plus 2. We got rid of our fractions, which is always important when you're solving. So let's distribute now and then solve for x. Okay, so let's distribute and get rid of the parentheses. Same thing on both sides. So we get x squared minus x plus 1. Over here we get x squared plus 2x plus 3x plus 6. Okay, move all the x terms on, and if you notice on one side the x squares will cancel because they're exactly the same on both sides. Okay, so I get minus x minus 2x minus 3x is equal to 6 minus 1. So I move these two to the left and I move the 1 to the right. You add these guys up, you collect them up, so you get negative 7x is equal to, it would have been nice if this was a 7 too, but it's actually a 5. So you divide both sides by negative 7 because you want x by itself now. So x is equal to 5 over negative 7. Okay, and there's your answer. You can check your answer if you have time, but you should definitely check for division by 0 since x is in the denominator. When will this be 0? When x is negative 2. Is negative 2 our answer? No. When will this be 0? When x is 1. 1 minus 1 is 0, so 1 is not our answer. So this is a good answer. You can definitely plug it in and check to see if the two sides are the same. So when you have two fractions equal, exploit the idea of cross multiplying. It speeds up the process. But if you want to do it the other way still, like I showed you this problem, you can still find the common denominator, multiply each side by it, and do it that way. It'll still work out perfectly fine. So use the method that you prefer, but don't try to cross multiply for problems where you cannot cross multiply. Okay, so sometimes students will start abusing that idea of cross multiplying. So let me give you another last example of that. Okay, so let's say if I have this, if I have 2 over x plus 1 is equal to 4 minus 2x over x plus 1. Now I don't have two fractions equal here. I have one. Technically this is a fraction. I have three fractions, so I can't cross multiply here. But I still have fractions and an equality, so my goal is to get rid of the fractions. So let's find the common denominator. You don't have to factor anything. I only have one factor, x plus 1. The highest power is 1, the highest power is 1, so just get 1. So let's multiply each term by x plus 1. So we get this is equal to, we get x plus 1 times 4 minus x plus 1 times 2x over x plus 1. Okay, so what happens on the left hand side in this term, because this is technically over 1, I can cancel things from the top and the bottom, so this cancels, so I just get a 2. Out here I can distribute because there's no fractions here, so we get 4x plus 4. Out here the x plus 1's cancel, so you get minus 2x. I want to solve for x. I want x's on one side. Since they're already on one side, I'll just move the 4 over. So you get 2 minus 4 is equal to 4x minus 2x. So I get negative 2 is equal to 2x. So you divide both sides by 2 because you want x by itself. So you get negative 2 over 2 is equal to x. So this tells me x must be minus 1. Okay. Now since x was in the denominator, we should take a minute and check our answer. If you can clearly see, if x is minus 1, you'll get negative 1 plus 1 is 0. So this cannot be the solution. That tells me I have no solution to this problem. Okay, but everything that we did was perfectly fine here. So you should always make sure that, once you get a solution, don't get happy about it. A lot of the time students are always in a hurry. They'll get excited. They found a solution. They'll try to move on to the next problem. But take a few minutes and check your answers. And especially if the variable term is in the denominator, always check for division by 0. Okay. If you have any questions, make sure you guys give me a call, or else just practice the homework problems to master the concepts.